Hello. So there are multiple parts to this problem. So first, we need to figure out what is the molar mass of our compound hydrated sodium carbonate. Okay, so let's start with the formula. So here it's Na2CO3 dot 10 H2O. Okay, so you can figure out the molar masses by looking at the periodic table. So for example, sodium is approximately 23, carbon is approximately 12, oxygen is approximately 16, one hydrogen is approximately 1, and oxygen is approximately 16. So what we have for the molar mass, so molar mass equals 23 times 2 because there's 2 sodiums, plus 12 because there's only 1 carbon, plus 16 times 3 because there are 3 oxygens, and every oxygen has a molar mass of 16, plus, so here it's 10 times 2, so this gives us 20 hydrogens, and they each have a molar mass of 1, plus, and here it says you have 10 oxygens. So you have 10 oxygens and all of them have a molar mass of 16. So when you add this all up, you should get 23 times 2 plus 12 plus 16 times 3 plus 20 times 1 plus 10 times 16. You get an answer of 286 grams per mole. Great, so now this means that our first answer is going to be D. Okay, so now for the next part, it's telling us that we have to figure out the volume of carbon dioxide given off. So centimeters cubed, it's the same as milliliters. Okay, so let's see. So we need the ideal gas equation. So this is PV equals nRT. Now something interesting to note is that it gives us the temperature. So let's see what's given. So 18 degrees Celsius. We can convert this into kelvins by adding 273.15, which would give us 18 plus 273.15, 291.15 kelvins. It also gives us pressure of 95 kPa, so we can leave this one alone. When you use the constant 8.31, so I'll just write it on the side here. So if you use a constant 8.31, the units for this constant, it's liters times kPa, and there's also kelvins and times mole. So as long as your units are in liters, kPa, kelvins, and moles, you can use 8.31 and it's fine. So so here for pressure, we have kPa, great, and we have kelvins, great. So what else do we have here? It's giving us mass, 1.22 grams of hydrated sodium carbonate. And we also have the molar mass down here because we figured that out. So molar mass equals 286 grams per mole. So since you have mass and molar mass, you can find out the moles because moles is N equals little m over big M. So down here, this is actually big M. So let's see. So you have 1.22 divided by 286, and you should get 4.26 times 10 to the negative 3. Just a note, in this question, I am not factoring significant figures. So if your teacher requires you to do that, please do that. Okay, so now we have PV equals nRT. We have P. We need to solve for V. We have N. We have R. R equals 8.31. and we have T. So let's plug it in. So P is 95, V we don't know, and we solve that. It's 4.26 times 10 to the negative 3 times R is 8.31 times T, which is 291.15. So from here, V equals, so you're going to multiply everything on the right side and then divide by 95 once you're done. So 4.26 times 10 to the exponent negative 3 times 8.31 times 291.15 equals, so I get, so from here you're going to multiply 4.26 times 10 to the exponent negative 3 times 8.31 times 291.15, and from here you get 95V equals 10.31, and to solve for V you're going to divide by 95, divide by 95, so V equals, so 10.31 divided by 95, you get 0.108 liters, but you're not finished yet because the question asks for centimeters cubed, so this converts into 108 milliliters or 108 centimeters cubed.